Welcome back. We're still talking about hypothesis testing with two variances, left tail test. Since we've done a couple of full-blown word problems to read them and to pull the information out, now we'll do another quick problem that's not, I'm just going to give you the raw information, but we're going to do the same hypothesis test. So what if I give you that n sub 1 is 11, that s sub 1 squared is 31,207, right? And then I also give you that n sub 2 is equal to 11. And I give you that s sub 2 squared is 38,916. And then I also give you the claim that sigma 1 squared is less than sigma 2 squared, and I give you the level of significance 0.01. So the goal is here, this is all the information that you would get out of a typical word problem. You're given some claim, population variance from population 1 is less than population 2. Now, we are also given the raw data. To test this, we sample 11 items from population number 1. We get this. We get 11 items from population 2, and we get a bigger number. So it looks like at first glance, this number is smaller than this one, so the population variance, it seems to kind of match up with what we have here. But we're testing at a 0.01 level of significance, which is 99% level of confidence. We want to see if this is enough data to statistically say it's significant that we can draw this conclusion or not. So we need to set up our hypothesis test. Okay, so the first step in all of these things, other than writing the data down, which we've already done, is to write down the null and the alternate hypothesis. Now, the alternate hypothesis is always going to be the claim that you are making. I've said this many, many times. So I say claim, that is the alternate hypothesis, and it's just written right here, so I'm just going to copy it again. Right now, if this is the claim, then the alternate, or I should say the null hypothesis, is the exact mathematical opposite of what we've written here. So sigma 1 squared is going to be greater than or equal to sigma 2 squared. Right? So here we have the null and the alternate hypothesis. So are we going to reject this null hypothesis and go with this one, or are we going to fail to reject it, which means we stick around and say that that one is what we believe is true at a 99% level of confidence or 0.01 level of significance. So it's immediately helpful, once you get the data kind of written down, to draw a little graph of what's happening. I do this for every single problem. Okay, so here you go, that's your F distribution. It starts at 0. Now you look at your alternate hypothesis, there's a left-hand arrow, which means this is a left tail test, which means that there is a critical value of F such that the shaded area under this curve is what? Alpha. And alpha is given in this problem to be 0.01. So the shaded area to the left here is 0.01. And for left tail test, or for left-hand test, we label this critical value 1 minus alpha. Actually, I don't really care what you label it, but it's a critical value, so I'm gonna label it like this because of reasons I've mentioned in other videos. So essentially we call this F1 minus alpha. That is going to be the rejection region that we're going to read off of the chart in order to solve this problem. Okay, now the test statistic that we're using for all of these problems is S1 squared over S2 squared. Now from the numerator we can get the degree of freedom of the numerator, which is going to be how many samples, which in this case is 11 minus 1. Which means 10 is the degree of freedom of the numerator. And then we have the degree of freedom of the denominator, which in this case we actually sampled 11 times in both cases, so essentially it was the same thing, 11 minus 1, which is 10. Now if it were a right tail test, we would go to the chart for a 0.01 level of significance, and we'd read the